Hello grade 12s, we are looking at another mechanical analytical question, and we are going to run through the questions 1 to number 18 on your right hand side and answering those questions pertaining to the drawing that we have on our left hand side. So you will either find some of the answers here, or it alternatively will be in your title bar. I'm going to zoom in so that we can proceed with question number 1. So question number 1 is, what is Ingrid's responsibility? And we go down to the title bar and we find the name Ingrid attached to the checking of this particular drawing. So Ingrid's responsibility was checking the drawing. What is the manufacturer's website address? We go back to the title bar and we find the address here as www.foundry.co.za. And that is the answer you will write in here. What is the file name? We go down again to the title bar and we will find the file name is MJIG-12-V5. That will be written in this space here. Who is the client? Which is number 4. The client has no specific name, but the client in this particular instance will be the company called Cast Form Engineering. And they are situated in Broad Street, Middelfontein. So that is the answer to number 4. Cast Form Engineering. Number 5, how many jigs must be manufactured? We go down to the quantity, and that indicates 30 units, which means 30 of those jigs will be manufactured. Number 6, what is view 1 called? So we look at the label view 1 and we have view 2 as well. So of course you can see that view 1 will always be the front view, reason being that view 2 is the top view, and view 2, which is the top view, is always situated above the front view, hence view 1 being the front view. And that is how you find the different views should you be requested to answer these questions. And you will also look further at this drawing that this view has been cut, so it is a sectional front view. You can further establish this as a sectional front view. If we go to number 7, what type of section is view RR? So if you look at view RR, there's the cutting plane of view RR. It has been taken out to show the shape of that specific area. That is classified to be a removed section. It has been removed outside of the drawing and placed in this space here, which makes that a removed section. We go to the next one, which is number 8. We ask the question, name the type of section produced by cutting plane TT. So if you look at cutting plane TT, it starts here, it then goes up through the hole, drops down, and it finishes off this side here. That is an offset, or it can be recorded as a multiplane, or alternatively it can be regarded as a staggered section, a staggered cutting line, or a staggered section. One of the 3 answers can be written in this space here. Offset, or multiplane, or staggered. Number 9, determine the complete dimensions at A, B, C, D, and E. Let's go look at A. So we will find that A is situated in this corner here, and you will find many of those corners. Those corners are called fillets. The dimension of those fillets has not been given to us, but if you scroll down to your title bar, you will find that it states that all unspecified radii are 4 millimeters. And that is your first answer at A. If you look at B, you will find that B is situated right here. The distance between that line here and this end here, you're not going to find the answer here, but if you scroll down, you will find that it is on a slant of 45 degrees, And if this side here is 15 and you have a 45 degrees, mathematically you are going to have 15 millimeters from this point here until this end as well. So that answer is going to be 15 millimeters for B. Number C, if you go to C, you will find that C is situated right here. That is a little slot there that you will find. There's another one on the opposite side. No information has been given there, but if you scan, you will find that the same slot appears here from the top view. The dimensions have been given here, so that means that the distance in between here is going to be double the R6, because R is radius from the center to the outside, and double that is going to be R6 times 2, which is going to give you diameter of 12 in the space of C. If we go down to our drawing and we find D, D is the distance from the top until the bottom. So what you are given is the dimension of 44 stretching from here until the center here. There is no dimension given to here on this particular drawing. These are all referring to these heights over here. But if you scan over to your remove section, which is view RR, you will find that view RR reflects this cutting plane that you will see here, which means that you will find the distance of 15 and 25, which is 40, added the 44, which gives you 84 millimeters as the answer to D, stretching from the bottom until the top. So if you look at E, which is the final dimension, we request the dimension for E. Now if you look specifically at where the dimension is requested, it is the inside part of the internal thread. The outside part, of course, is a different measurement to the inside part. If you go and scroll up here, you're going to find that the outside diameter is going to be M10. That is for the outside circle, M10. But of course, it states here that M10 times 1.5 So the thread is 1.5. So it's 1.5 this side here and 1.5 on the other side. The distance inside from the outside thread. So that means 1.5 times 2, which is 3 millimeters. And the 3 millimeters must be deducted from the M10, which gives us a diameter of 7. So the outside part is 10 minus 1.5 on the one side minus 1.5 on the other side leaves us with 7 diameter. So 7 is the answer to the letter E. Number 10, determine the total length of the jig. So if you look at the front view, you will find we need the length from the start here until this finish here. It is not given to us. The length you have is from this distance here until that distance over there, which is 154. So if you are going to scroll up, you're going to find this distance right here, which is 6. So that 6, which is added to 154, is going to give you 160. And if you look at this distance here, you're going to find that the distance from that center line to the end here is going to be 15. And that is where you're going to find that 15, which is the same distance from here to there. So 15 will then be added to 160, which leaves us with a total length of 175. If you look at number 11, name the feature at F. So we're going to have to find F here. F refers to this little part that's left unhatched. So if you look at your remove section, you will find that F refers to this thin part here, which also refers to the inner dash line that you will see here. So rib or web is your answer. Number 12, what is the minimum depth of the thread required for the hole at G. So we're going to go to G, and G is going to be found right here. So the depth from that top point until this point over here, we're not going to find it here. We do, however, have the description here, M10 times 1.5 thread, and the minimum depth is going to be 18 millimeters. And 18 is the answer that you are going to fill in at number 12. Number 13, name the feature at H. So if we go and have a look at H, H refers to this specific area that has been opened, which is a gap, and it follows with the slot that you see here, which a bolt is going to put in flush with the top of your surface that you will see here, and that is called a countersunk or a counter bore. So the answer to that can either be a countersunk or a counter bore. Number 14, how many surfaces of the jig must be machined? So we're going to look at our machining symbols and we're going to count those symbols. So this is a very technical question because you have to look at these little symbols that you will see here. So we count 1 here for that surface, 2 for that surface, 3 for that surface, 4 for that surface, 5 for that surface, 6 for this surface over here. But you will find that that symbol there represents this surface here. And how many of these are there? Another one which is 7 and another one which is 8. So you will write in the answer 8 in answer block 14. Number 15, for 2 marks, describe the hatching mistake on view 1. So if you look at view 1 and you scan all over, these are all the hatching lines. They're all in this direction except that there, and that is the mistake. This is one component and the hatching should all be in one direction. That is the mistake, that the hatching flows in the opposite direction. So the answer that you will have here as the mistake, hatching in the opposite direction, which is your answer to number 15. Number 16, with reference to the tolerance, determine the minimum height at J. We're talking about the minimum height at J. So if you go to J, this is where J is, that's the height. But if you go down this line, you will find that J has that height of 31 millimeters. But if you zoom in on this specific area here, which I'm going to do, you will find that there's plus 0.25 and minus 0.1. The plus is the upper or maximum. If you should request to write in the upper or maximum, which is 31 plus 0.25, gives you an answer of 31.25. But that is not the answer requested in this particular instance. You are requested the minimum. So you will have to take 31 minus 0.15, which basically leaves you with 30.85. And 30.85 is what you are going to write in here. Number 17, with reference to the machining symbol below, and which is that symbol over there, match the letter on the symbol with the correct label in the column to the right of this question, which is here. So you have the options of direction of lay, roughness value, sample length, machining allowance, and it counts 4 marks. The direction of lay will be symbolized here, which is D. So D is going to be your direction of lay. So it can be cross-sectional, perpendicular. Those are all directions of lay according to your notes. So D is your answer here. If you look at the roughness value, that will be written at A. That is the value of the component written as a decimal. Your sample length is going to be C, and E is going to be giving you the machining allowance on the symbol. So just to recap, direction of lay will be D, your roughness value will be A, your sample length will be C, and your machining allowance will be E. You go on to number 18. In the space below, draw in neat freehand the symbol for the projection system which was used. And of course, learners, this symbol is not unknown to you. Of course, you have been given a center line. You will start with a center line here, which will give you half a mark, a small circle for half a mark, a big circle for another half a mark. You will have a representation here of a line of the small circle, representation of the longer line of the big circle, and the two sides will join in a slanted motion. That will give you a total of 8 half marks, which will result to 4 full marks. Grade 12, that brings us to the end of this particular mechanical analytical. I hope that you have found this particular activity very informative in preparation for future tests and exams to come.